Hi friends, good morning to everyone. Welcome to my channel Belagali's class. Belagali's class. Well friends, I have done 3 classes in case of what? Pair of linear equations in 2 variables. Pair of linear equations in 2 variables. I have done 3 videos, 3 classes, almost all the basics. In the first class, just I covered the pair of lines studied in 9th standard. One full video is a repetition. I have explained each and every basics in case of what? Pair of linear equations in 2 variables. In the second and third, just I went through the standard form of a pair of linear equations. A1x plus B1y plus C1 equal to 0, A2x plus B2y plus C2 equal to 0, in which A1 not equal to 0, B1 not equal to 0, A2 not equal to 0, B2 not equal to 0, such that A1 square plus B1 square is not equal to 0, A2 square plus B2 square is not equal to 0. Everything is explained by friends. Explained. Then when there are 2 equations, a linear equation always represents an equation to the straight line. It represents a straight line. 1. When there are 2 equations, 2 linear equations, graphically they represent what? 2 lines. 2 lines. 2 lines means there exist 3 different cases. 3 different cases. Yes, my friends. 3 different cases or 3 different possibilities. These are the equations. The first possibility denoted by what? P1. P means possibility, 1 means first. P1. L1 and L2. Lines L1 and L2 may intersect at a point. Intersection is always at a point back. 2 lines never intersect more than in 1 point. If they intersect, always they intersect at a point. Single point. Intersect. Then that we have proved number of common points is 1, then it has a unique solution. Everything we have explained. So in the case of what? When the lines intersecting type, the solution is unique, only one solution. One value of x and one value of y, pair. Second possibility, the lines L1 and L2 may coincide. This is the line L1, another line may coincide, may overlap, may lies on another one lies on another line. Coincident it is called as coincident. In this case the lines are coincident. When the lines are coincident, you are observing both have infinite number of common points. A point which lies on the line is a solution of the equation. Everything explained by friends. So infinite number of points, common points, indicates there exist infinite number of solutions. Infinite number of solutions. There is only one common point. There is only one point which is common to both L1 and L2. Both common to L1 and L2, my friends. L1 and L2. There is only one common point. Means P is a point which lies on both L1 and L2. Therefore, there exists only one solution. A point which lies on the line will be the solution. P is the point which lies on the line L1, L2. Therefore, in case of intersecting type, there exists one solution. One mathematical language is unique solution. Unique solution. Coincident, you are observing number of infinite number of points are common. Therefore, there exists what? Infinite number of solutions. Infinite number of common points indicates infinite number of solutions. So, coincident type has an infinite number of solutions. What is the third case? Not coincident, not intersecting means what? The lines are parallel. Third case, third possibility. When the lines are parallel, no common point. A point which is common to both L1 and L2 gives the solution of L1, L2. When there is no common point, in this case, my friends, there is no solution to the system of equations. Why? In this case, no common points, therefore no solution. So, the linear equations of the parallel type, no solution, intersecting type, one solution, coincident type, infinitely many solutions. My friends, remember everything we have done, and we have done a series of examples based on this. I don't want to again remind everything, just to see them, the types of the examples which we have done. Later comes with what? Methods of solution. In this case, my friends, there are two methods. One is a graphical method. It is also known as geometrical method. Means you have to draw the graphs, you have to draw the figures. With the help of that, we are deciding the solutions. Even we have done a series of examples on graphical or geometrical methods. We have find what? The solutions of the linear equations. Till it is continuation, still we are continuing this graphical method only. Now what is the second method? Second method is algebraic method. Still we have not yet started. Still we are doing graphical methods. In that, my friends, next one is consistency and inconsistency of system of pair of linear equations in two variables. What is it? Consistency and inconsistency of system of pair of linear equations in two variables. Then what is the definition? A system of pair of linear equations. A pair of linear equations. It is understood in two variables, namely a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0 are said to be consistent. First definition it is. Are said to be consistent if it has, my friends, this is a very, very important word, at least one solution. At least one solution means minimum one, and what is the maximum? Any number of solutions. Therefore, means it has one or more than one solution. More than one solution. More than one solution. Has one or more than one solution. If the system has one solution means what? It is consistent. Even it has not only one, if it has more than one, the system is said to be consistent. Now you can give a link to this one. Intersecting type. Intersecting type, there is a one solution, unique solution. In this case, the system of equations which are intersecting type are consistent. My friends, this system is consistent. What about the second? In case of the lines which are coincident, it has infinite number of solutions. My friends, note it. Solution exists. The solution is what? Infinite means what it is? More than one solutions. More than one solutions. One and more than one. In this case, the system is said to be consistent. In this case, my friends, even coincident type also, the system is said to be consistent. Intersecting type, the system is said to be consistent. We identified this because by the definition, if the solution exists, then that system of equations are said to be consistent. Solution exists, system is consistent. One solution, unique, intersecting type, consistent. Coincident, solution exists, but solution is what? Infinitely many. You mean more than one solution. More than one solution is there. Therefore, even in this case, coincident type, that type of equations are also said to be consistent. The same thing I have consistent. In this case is also consistent. I have written here. Now, thus, intersecting and coincident type of equations are consistent. Next, and the system is said to be inconsistent. Inconsistent if it has no solution. If it has no solution. No solution means what? When the system is parallel. So, if the system is parallel, in this case, the system of linear equations is said to be inconsistent. Inconsistent here. Consistent. Consistent means what? The equations are correct. Inconsistent means the equations are not correct. Not correct. They are wrong equations. Wrong equations. Understood? Yes, my friends. So, with the help of these definitions, consistent solution exists. Solution may be one or may be more than one. So, in case of what? Intersecting, there is one solution. So, the system is consistent. Coincident, the system has more than one solution. So, the system is consistent. Therefore, in case of intersecting and coincident type of equations, the system of equations are always consistent. Inconsistent, my friends, next definition is what? Consistent, opposite, inconsistent. Solution, opposite, no solution. Solution, consistent, no solution is inconsistent. So, in case of what? The parallel lines, there is no solution. Therefore, the linear equations of what? Parallel type are always inconsistent equations. The system is inconsistent. Yes, my friends. Remember, solution, whether it is one or more than one, consistent, absolutely there is no solution. Inconsistent. Opposite to the consistent is inconsistent. Opposite to the solution exists is what? There is no solution. No solution. My friends, remember, finally parallel type, inconsistency. This. Now, this we directly identify. Next result is this consistent and inconsistent we directly observe by these three different cases. These are the linear equations, pair of linear equations. Then these are the observations. What is the first observation? If A1 by A2 is not equal to B1 by B2, this one. A1 by A2 is not equal to B1 by B2. In this case, the system of equations L1, L2 intersect at a point. Intersect means it has a unique solution. Unique solution means in this case the system is consistent. What is second case? All the three ratios are equal. In this case, the system is said to be coincident. Coincident means it has a solution, but the number of solution is what? Infinite. There is a solution, the number of solution is infinite. As there is a solution, even in this case, the system is said to be consistent. In this case, my friends, the ratios are equal. Ratios are equal means they dependent. If it is 2, down is 4. If it is 3, down is 6. If it is 5, down is 10. But the ratio is what? 1 by 2. It is named as dependent equations. What is third one? A1 by A2 equal to B1 by B2 but not equal to C1 by C2. All the three equal, consistent. This is false in this case, my friends. So in this case, the solution does not exist. No solution. No solution means the system is inconsistent. No solution, the system is inconsistent. Thus, my friends, in these equations, if it is A1 upon A2 not equal to B1 upon B2, intersecting type, solution exists, unique, consistent. All the three are equal, coincident, infinitely many solutions, the system is consistent. A1 upon A2 equal to B1 upon B2 not equal to C1 upon C2. In this case, the lines are parallel, hence there is no solution. No solution means what, my friends? It is inconsistent. Hence, my friends, based on this, you have examples in exercise 3.2, my friends. Some 2-3 varieties of the examples are there. on consistency and inconsistency of pair of linear equations. Yes, my friends. I give 2 minutes. Please copy it. Then I do examples from exercise 3.2. 3.2. Yes, my friends. Copy it. Copy it. Yes, my friends, I have written everything with a tabular form in brief. This is the system of linear equations, pair of linear equations, in which this is the first case, a1 upon a2 equal to b1 upon b2. It is an intersecting type in this case, my friends. Intersecting means the solution is unique, and the solution exists means the system is consistent. If all the three are equal, then the pair of lines are coincident. Coincident means there exist infinitely many solutions. But as there exists a solution, the system is consistent. It is a dependent type. One equation depends on other equation. Dependent type. Third, these two are equal but not equal to the third. It is a parallel type. Parallel type means no common points, no solution. By the definition, the system is inconsistent. Yes, my friends. Now, I do examples based on this. Yes, my friends. Again, examples from exercise 3.2. This is example number 2. 3.2, example 2. Example 2. It is the statement on comparing the ratios A1 upon A2, B1 upon B2, and C1 upon C2. Find whether the lines representing the following pair of linear equations are intersecting. My way of writing this is intersecting or coincident or parallel. Yes, my friends. This is the first example. This is the first example. Yes, my friends. The first example, you have to test for what? Intersecting, coincident, parallel. When it is intersecting means this ratio is equal. Coincident means this ratio is equal. Parallel means this result. First two equal, not equal to the third one. Yes, my friends. The system of equations are 5x minus 4y plus 8 equal to 0. This is first equation. 7x plus 6y minus 9 equal to 0. Yes, my friends. To decide intersecting, coincident, parallel, you have to test these ratios. These ratios directly indicates A1 upon A2, B1 upon B2, C1 upon C2. If not, compare these with standard. Write the values of A1, B1, C1, A2, B2, C2, then find ratios. One example I do in detail. Next example I take A1 upon A2 means this coefficients of x. Here, here A1 is 5, B1 is minus 4, C1 is 8, A2 is 7, B2 is 6, C2 is minus 9. Yes, now this is A1 upon A2. A1 is 5, A2 is 7, B1 upon B2. It is minus 4 upon 6, minus 2 by 3. This itself indicates what? A1 upon A2 is not equal to B1 upon B2. Yes or no? This is 5 by 7, it is minus 2 by 3. These two are not equal. When it is A1 upon A2 is not equal to B1 upon B2, it is what? Intersecting type. It is intersecting type. Yes. Yes, implies the system of equations are intersecting type. Anyway, friend wanted only what? Whether it is a intersecting, coincident, parallel. You have to write only it is intersecting type. If it is intersecting type, the lines are consistent. Implies this. Don't write. Because not asked. Given lines are consistent. Yes, my friend. Next is second example. Example 2. Second example. Nine x plus 3y plus 12 equal to 0. Third one, 18x plus 6y plus 24 equal to 0. Here it's a direct, I write, my friends, here. A1 upon A2, coefficients of x. See here. What is A1 and A2? They are the coefficients of x. What about B1 and B2? Coefficients of y. What about C1 and C2? They are the constant terms. Yes. A1 upon A2, 9 by 18. What is it? 1 by 2. B1 upon B2, 3 by 6. 3 by 6 is 1 by 2. Then C1 upon C2, it is 12 upon 24, is also what? 1 by 2. This implies, my friends, what it implies, A1 upon A2 equal to B1 upon B2 equal to C1 upon C2, and they are all equal to 1 by 2. When all the three are equal, coincident type of, therefore the lines are coincident. System is consistent, dependent. Yes, in this case, lines are coincident type. Lines are, pair of lines are, pair of given lines are coincident type. Coincident type. Coincident type means what, my friends? Consistent, dependent. I write this inside the bracket 5. The friend wanted only this, no consistent, inconsistent. Coincident type. This is second. Third, this third example I give for what? DIY. And that equation is 6x minus 3y plus 10 equal to 0. 2x minus y plus 9 equal to 0. See, my friend, a1 upon a2, 6 by 2 means 3. What is this? Minus 3 upon minus 1 is 3. Then a1 upon a2 equal to b1 upon b2. What about this? c1 upon c2 is 10 by 9. This is not equal. Then what is the case, my friend? a1 upon a2 equal to b1 upon b2 not equal to c1 upon c2. Parallel type. The given equations are parallel type. Yes, my friends. Just this is one. This is example 2. Example 2 here. Next is, my friends, example 3. This is 3 here. 3 here. Yes, the statement is, on comparing the ratios a1 upon a2, b1 upon b2, c1 upon c2, find whether the lines following pair of lines find out whether the following pair of linear equations are consistent or inconsistent. Yes, my friends, for consistent, inconsistent, in the first two cases, the equations are consistent. In the third case, where not equal to c1 upon c2, it is inconsistent. Just, my friends, verifies. First example, example 1. The given equations are 3x plus 2y equal to 5. 2x minus 3y equal to 7. What is the first thing, my friends? First thing, you must write it in the standard form. Yes. These written as 3x plus 2y minus 5 equal to 0. 2x minus 3y minus 7 equal to 0. Yes, my friends. a1 upon a2, coefficients of x, 3 by 2. b1 upon b2, it is 2 by minus 3 is minus 2 by 3. What is your observation? Observation is what? a1 upon a2 not equal to b1 upon b2. When a1 upon a2 is not equal to b1 upon b2, in that case the system is consistent. Intersecting type consistent. So it is intersecting type. Intersecting type means the solution exists, and hence the system is consistent. System is consistent. It's simple. 2 more questions. Next example is. Yes, 3 by 2 into x plus 5 by 3 into y equal to 7. 9x minus 10y equal to 14. Yes, my friends. Simplify it. So a1 upon a2. What is a1? 3 by 2 upon 9. Simplify. So this is 3 by 2 into 1 by 9. 3 cancels with 9. It is 1 by 6. Yes. B1 upon B2. What is B1? 5 by 3. Down is minus 10. Simplify. 5 by 3 into 1 upon minus 10. Yes. 5 cancels with 10. What is it? Minus 1 by 6. This is 1 by 6. It is minus 1 by 6. This itself implies a1 upon a2 is not equal to b1 upon b2. Then it is intersecting type. Intersecting and coincident means what? The system is consistent. Yes, my friends, if you wanted, I do one more example. Consistent. Yes, copy it. Consistent. The next is another example. This is the third example. The equations are 4 by 3 into x plus 2y equal to 8. 2x plus 3y equal to 12. These are the given equations. Yes, friends, first write it in the standard form. Then you compare. Yes, friends. A1 upon A2. This is 4 by 3 upon 2. Simplify it. 4 by 3 into 1 by 2. Cancellation. Simplifying, you get 2 by 3. B1 upon B2. What is B1? 2. B1 is 2. C1 is 3. Yes, they are equal. Then you have to find when A1 upon A2 equal to B1 upon B2, you go for the next third. C1 upon C2. It is minus 8 upon minus 12. Why? My friend, you must take this side, you must take this side. What is this? It is also 2 by 3. Then from this, what is clear? All the three are equal. C1 upon C2 implies when all the three are equal, my friends. The lines are coincident type, and hence it is consistent dependent. So lines are coincident. and they are consistent. They are consistent. Then one example just to try yourself, my friends. You try yourself. One example, you try yourself. This is two x minus 3y equal to 8. 4x minus 6y equal to 9. See, my friend, a1 upon a2, 2 by 4 means 1 by 2. b1 upon b2, minus 3 upon minus 6 is 1 by 2, equal. What is c1 upon c2? Minus 8 upon minus 9, not equal. Third type, parallel, lines are parallel, no solution. The system is inconsistent. In this case, the system is inconsistent. The given equations can be written as minus 8 equal to 0. It is minus 9 equal to 0. So, my friend, a1 upon a2, 2 by 4, 1 by 2. It is b1 upon b2, minus 3 by minus 6, 1 by 2. And c1 upon c2, it is minus 8 upon minus 9, which is 8 by 9. Tell my friends. This gives a1 upon a2 equal to b1 upon b2. These two are equal to 1 by 2. But not equal to c1 upon c2. But not equal to c1 upon c2. By the third case, lines are parallel. Parallel, therefore, no solution. No solution means the system is inconsistent. No solution means, by the definition, the system is inconsistent. System is inconsistent. Yes, my friends. Note these things. These things. Yes, my friends. Based on this, the next type of examples are yes, my friend. Same exercise 3.2. This is example number 3. Next comes example 4. Exercise 3. Next is example 4. Example 4. Yes, friends. In this man, example 4. Yes, the system is inconsistent in this case, my friends. These are very simple examples. Either 1 mark, otherwise 2 mark, they give such examples, my friends. Next, example 4, in exercise 3.2. This is the statement of this example 4. Which of the following pairs of linear equations are consistent, inconsistent, consistent or inconsistent? If it is consistent, obtain its solution graphically. Its solution graphically. Yes, my friend. In 4, it is first example. In example 4, it is first example. Given equations are x plus y equal to 5, 2x plus 2y equal to 10. Yes, friends, this can be written as, taking this side, x plus y minus 5 equal to 0. 2x plus 2y minus 10 equal to 0. Yes, ma'am. Find a1 upon a2. Here it is 1, here it is 2, 1 by 2. b1 upon b2, tell my friend, it is also 1 by 2. Then what about c1 upon c2? It is minus 5 upon minus 10. See here. c1 upon c2, constant terms. Simplifying, it is also 1 by 2. So, my friends, this gives a1 upon a2 equal to b1 upon b2 equal to c1 upon c2, and all the three are equal to only 1. Ratio, that is 1 by 2. When all the three are equal, the system is what? Coincident type. System coincident type. Coincident lines and system of equations. Equations are consistent. I told my friends consistent, dependent. Tell why dependent. The second equation we got it by multiplying the first equation by 2. Who is the hero? Hero is the first equation. What is second equation? Hero, and why tell? Multiplying the first equation we got second. Second equation mainly depends upon first. Therefore, the ratios are equal. Even though the solution exists, solution is what? Infinitely many solutions. Solution exists, because of that the system is consistent. System is consistent. Next, my friends, graphical representation. Yes, graphical representation. My friends, this is L1. Minus 10 equal to 0. My friends, this is L2. This is L2. You know how we have done so many examples to draw the graphs. Yes, graphical representation. Graphical solution concept. For L1, what is it? It is x plus y minus 5 equal to 0. Get the value of y. Y equal to minus becomes plus, plus becomes minus. Go for the tabular form. Values of x, values of y. You get minimum 2, maximum 2. Yes. My friend, when x is 0, what about y? Put x equal to 0. 5 minus 0 is 5, y is 5. When x is 2, 5 minus 2, y is 3. When x is 5, 5 minus 5 is 0. 5 minus 5 is 0. This is for L1. L1. Then for L2. Then for L2. What is the equation? 2x minus 2y minus 10 equal to 0. It is 2x plus 2y. Therefore, 2y equal to minus 10 becomes plus 10. Plus 2x becomes minus 2x. Divide by 5. 10 by 5. 10 by 2. 2 by 2 minus x. Once again, see my friends, equation is same. Y equal to 5 minus 6, y equal to 5 minus 6. You get what? Same values of x and y. Same common points. See. When x is 0, what about y? 5 minus 0 is 5. When x is 2, what about y? 3. When x is 5, what about y? 0. See. Almost, why not? Exactly. The tabular form of L1 is same as the tabular form of L2. Hence, the points 0, 5, 2, 3, 5, 0 dash lies on both lines L1 and L2. So, my friends, this implies the points 0, 5, 2, 3, 5, 0 like that when you get lie on both lines L1 and L2, and hence they are the common points on L1 and L2. On L1 and L2, you draw the same graph. I have taken almost all positive values. Yes. Origin starts with 0. I wanted 5 here, above also 5. So this is 1, 2, 3, 4, 5. Right. Indicate. This is x-axis. Here also, my friend, 1, 2, 3, 4, 5. My friend, this is y-axis. See. When x is 0, y is 5. When x is 0, y is 5. Same here also. When x is 0, y is 5. And when x is 5, y is 0. When x is 5, y is 0. What is another one in between? Therefore, yes, my friend, this is line L1. In between 2, 3, this is 2, this is 3. This is 2, this is 3. On the same lines, you can mark. This is L1. Same. This is what? For L2 also. For L2 also. This is L2. So, L1 and L2 coincide. So, lines L1 and L2, coincident lines. Coincident lines exist what? Infinitely many solutions. Then the system is consistent. It implies infinitely many solutions, and the system is consistent. consistent lines. Yes, my friends. It is consistent. It is consistent. This is the graphical representation. This is L1, this is L2. All these are what, my friends? The points which are common on both lines L1 and L2. This is what? X0, 0, 5. What is this, my friend? 2, 3. What is this, my friend? X is 0, Y is 5. These are the common points which on L1 and L2. L1 and L2. This is the graphical representation, my friends. This is the third type of examples. Third type. If you want, I do one more example of this type in the next video. And I do some examples which are important for CET and IIT level questions, IIT, JEE level questions. I do them in the next video, next class. Till then, my friends, thank you very much first. Thank you. Thank you. Attending to the next class, please be prepared. Go through all these basic notes. If with the preparation, if you read, if you attend the next video, the things will be more clear. My friends, for more clearance, to become more happy, you must prepare the things which I have done earlier. Saying this, my friends, saying once again thank you. Namaste, namaskara, namaste, namaste. Yes, my friends.